Hi everybody! This presentation is for anybody who has digital 3D models, scanned or sculpted, they want to 3D print. I assume you already have knowledge about the 3D modeling application you're working with, but if you don't, this presentation might spark your enthusiasm for 3D printing and what it can do for natural science education. Here are some of the models I printed myself. They show how far you can go with 3D printing right in your own studio. Here, a skeleton you might know. It's the neck vertebra and the T1 and T2 of the rat. And these are all loose vertebra. Here, the urogenital system of that same rat, but now in a real life size, in this. And here, the anatomical snail in one go on my biggest printer. And here the same snail on a smaller printer, on the other one, but now I painted it. I'm going to tell you a bit about how to optimize your 3D models to get the most out of 3D printing. I'm not going to tell you about all the different printers out there, and I'm not going to tell you about all the different techniques there are, because of those things you can look up in abundance on the internet. What I will do, however, is give you some insights into best practices with the actual printing of the models and how I look at 3D printing compared to illustration and 3D modeling. Most of my experience is in resin printing. The reason for this is that the details in resin are crisp and layer lines are almost invisible, contrary to filament printing. A model printed with resin also feels more real, something I find important. Filament printing has advantages though. It's a lot cheaper, although that's changing rapidly. You can buy a 3D printer for as less as $100 or as expensive as $40,000. But the printers I'm talking about are between $400 and $1,500. For most purposes, you don't need to get more expensive than that. I have been printing since 2013 and got several printers. At this moment, only the Anycubic resin printers are live, the rest is collecting dust. These Anycubic printers are affordable workhorses, and after an initial learning period, the bigger the printer gets, the more prone they are to users' mistakes. I only get perfect prints. In the coming months, I will add 2 additional printers. A Rocket One Pro, which uses a different technique than most printers. Instead of pulling the print out of the resin after exposing the bottom of the resin vat, it prints by exposing the resin surface and sinking the print layer for layer down into the resin. It was a Kickstarter, so it's going to be a gamble if the printer does what they told us, but if it does, it enables even more possibilities. Gravity always is an issue with 3D printing, especially resin printing. The other printer is a Bamboo Lab X1 Carbon. This is my first filament printer in years and also came out of a Kickstarter. But this one is different. Instead of using the Kickstarter campaign to develop a product, Bamboo used it to market theirs. There are already loads of Lab X1s in the field and as a result also a lot of experience. The printer is plug and play and extremely fast for a filament printer. I will use this printer to experiment with detailed prints also, but I especially bought it because I can print in different colors with it. As with resin printing, I will experiment with it and stretch the limits of this printer too. So that's where I come from. 3D printing is for me mostly a way to be able to print my own designs. I'm very bad at selling them though, at least not to the general public. I do, however, use the knowledge I gain as a selling point for my actual customers, universities, research groups, and museums. For our profession, 3D printing can be used to educate and to get a better understanding of the objects we are researching. The anatomical models we are used to, the ones used in schools and at universities, are rather simple compared to real life. But with the current techniques, you can make models as detailed as you wish. You can show very detailed structures and stick more to the actual anatomy than with the old models. Of course, if you print detailed structures, the model is more prone to damage. One of the reasons the current anatomy models are comparatively simple. But because you can 3D print it yourself, you can always print a new one. So basically anything you can think of, plants, fossils, anatomy or skeletons, can be 3D printed. Like with illustration, you can not only 3D print an object as it is in natural life, but you can also show or hide structures for clarity. With the example I am showing, my by now almost famous anatomical snail, you can see that I didn't 3D print everything in the model, only the stuff that makes the model insightful. So I removed only half the shell to give people an understanding that they are still looking at a snail, and I removed the lung. Both shell and lung are suggested by the shape of the rest of the structures. The organs follow the shell and the veins follow the lining of the lung. The biggest advantage of 3D printing, in my opinion, is the fact that you can make stuff real for people. It invites them to touch, take it into their hands, turn it, and start investigating. Now on to getting models prepared for printing. To be able to print, you need special software that prepares your model for 3D printing. These are called slicing applications. What they do is cut your model into very thin slices. With filament printing, those slices are then interpreted and made into balls of a certain thickness, basically the outside of the model, and an infill. The infill is there to make the model firm enough. With resin printing, you can choose to hollow out the model or not. I only hollow out when a model is very big and would use up a lot of resin. Hollowing out with resin print has its own challenges because you are basically pulling a suction cup of the fab. The fab is the transparent sheet that forms the bottom of the vat the resin is in. It lets the light through that is used to solidify the resin. So if you are hollowing out, make sure you make holes in the model as close to the build plate as possible so the model doesn't pull a vacuum. Another issue with hollowing out with resin printing is the fact that you risk leaving uncured resin inside the model. There are ways of solving that by using thin UV LED strips inside the model to cure it, but your model still can crack over time. But I'm getting ahead of myself. Before your model is ready for the Slicer app, you first need to prepare it. And that is done in your preferred 3D modeling application. Mine is ZBrush, especially for complex models. Make sure you bake all the details into your model instead of keeping the subdivisions. And make sure all the surfaces are without any non-manifold issues. That means holes in your model, funky polygons, and so on. Sometimes a slicer application can repair a non-manifold issue, but it's better to solve these issues beforehand to avoid surprises when printing. The reason for this is that the Slicer app makes black and white images of each layer. White is what is getting printed. If there's a hole in your model, like I show you here, the Slicer doesn't know what to make white. So make sure your model is clean and solid. Digital 3D models are basically 2D surfaces shaped into a 3D form. There's no actual way to do it differently than this. So to be able to distinguish the inside from the outside, your models need to be one complete surface without any intersections or holes. If, for example, you want to print a model that exists out of different objects in one go, you need to make sure that the objects don't intersect or are fused to form one object. This last thing is easily done in ZBrush, for example, by using Dynamesh and setting the resolution high enough for the objects to fuse and the details still show. ZBrush has a function where you can check the mesh volume. This is a very handy function because it makes sure the model is completely solid. Once you have optimized your model, you can export it. Most people export it as an STL file, but a lot of slicers also can handle OBJs. It all depends on your preference. What I have encountered is that ZBrush doesn't give a clear size to models. Often I need to go through Blender to give a model a proper size, and even then the slicer application still can have a problem with that. Even though that's not always, it's something to take into account. I solve that by noting the size I make it in the slicer and noting the amount I scale it. This way I'm sure everything fits if I print a model with separate parts or if I want to redo the model for some reason. Now you are in the slicer application. For now I only talk about resin printing. You need to be aware of how a resin printer works. It fuses very thin layers of solidified resin. While printing, the resin will stick to parts of the model that are faced toward the build plate. This resin will partly solidify, which will make the details on that part of the model blur or even disappear. There will be parts of the model that are faced to the build plate, so one of the most important things in getting a great print is how you position the model on the build plate. To make matters complicated, the larger the surface that needs to be exposed per layer, the bigger the forces are on the model, making it prone to failure. Luckily, those restrictions mostly have the same solution. You angle the model in such a way that the surface per layer is as small as possible, thus making the slope toward the build plate also steep, enabling the resin to slide off the model as much as possible. If you also want to minimize the visibility of the layers, most of the time an angle of 45 degrees is okayish. This is for a layer height of 50 micron, which is the layer height mostly used in 3D printing. If really smooth surfaces are an issue, you need to calculate the arctan for your specific printer. This video, a link I will place in the description, will explain you how to do that. Now you can add supports to your model. The supports make sure your model is printed as you want it to print without distortion. The Slicer app will calculate overhangs, and most of the time the default settings are good enough to start with. Make sure you use the right thickness for the right model. Tiny models need thin supports, and of course, larger models thicker supports. If you use the default settings to add supports, make sure they aren't too close together. Remove the ones that do, so you get a nice and even support forest. Having done all that, you need to make sure you have the right exposure time for your resin. The best way to figure that out is to use a calibration model. The best one I've found yet is the Amira Labs TAM, which can be found on this blog. That blog gives you the latest model of the Amira Labs TAM. This blog gives you everything you need to know on how to interpret the model once you printed it. You probably will have to do this several times with different exposure times. Best is to start with the recommended exposure time for the resin you are using and go up and down in time depending on what you see when you print the calibration model. Now you are ready to put this value into your slicer application for that resin. Here, for example, my settings for my Anycubic Mono X with eSun plant-based white resin. I make sure the speeds aren't too high. Most of the time, a slicer has a lot higher default settings, but those are prone to failure. Better is to start low and work your way up. This video gives you a good insight into what settings does what and why. And now you're ready to slice and get your sliced model onto your printer. I can imagine that this sounds like a lot of work, but once you have dialed in your slicer application and your printer, it's basically slice and go. So that's it for the technical part. For now, a bit more insight in how I look at 3D printing. For me, 3D prints make science education much more interactive and much more accessible. It's relatively simple to get models out there and let students print them themselves. You don't have to worry that a model breaks because you can print it again and again. It enables you to show stuff that isn't easily explained in text or illustrations. Having said that, I approach 3D printing similar to illustration. Because I can choose what to show and what not to show, and how to show it, I can make models both insightful and beautiful. Even though 3D printing is a technique that has existed for decades, the evolution of the techniques is going at an astonishing rate at the moment. There are now 3D printers that can print objects in the same amount of colors as you can with printing illustrations in magazines and such. Those printers now still are in the tens of thousands of dollars, and the time it takes to print a relatively small object is insane, but I'm sure we will see affordable full-color 3D printers in a matter of years. So where does that leave us, natural science visualizers? The most important task is to make models that add to what is already there, in my opinion. We are people with a vast amount of knowledge of the natural world, and we are creative. Think of 3D printing as just another canvas to convey the beauty of everything around us. Use it to make people look at what's out there. Make them enthusiastic. So, I hope this presentation gave you something to think about and made you enthusiastic. I will take questions now.